Assalamualaikum. We are from Group 3, which consists of myself, Amil Fikri, Morgan Rice, and also Adi Akmal. So, we are required to accommodate water for 100 tourists for the span of 3 days. So now, moving on to our assumption. We found out that the average usage of water per person is 100 gallons per day. So when multiplied by the number of tourists, which is 100, and also the number of days, we got that the volume of water used is 113.55 meter cubes. So right now I want to talk about the water tank. The water tank that we're going to use is made up of galvanized steel with a density of 8.05 ton per meter cube, sigma yield of 500 megapascal, and also modulus of elasticity of 200 gigapascal. So right here you can see the dimension of our water tank. The volume is 5.734 meter cube with a mass of 46.156 tons. The maximum bending moment is 232.863 kN/meter, and we found out that the safety factor is 2.61, which is acceptable. Now let's talk about the upper platform. The upper platform, which holds the tank and water, is made up of mild steel with a density of 7.85 ton per meter, sigma yield of 370 megapascal, and also modulus of elasticity of 70 gigapascal. Right here is the dimension, thickness, the length, and also the breadth. The volume is 2.588 meter cube with a mass of 20.316 tons. We found out that the maximum bending moment is 994.939 kN/meters, and also after doing further analysis, we found out that the safety factor is 2.11, which is acceptable.
Okay, I will explain you about the structure of the pillars that we are going to use in the floating water tank. So when we and the structures that attach with attach surrounding the pillars. The first of all, we see this ladder. This ladder is mainly focused to be attached here, attached from the platform to the water tank, so that the workers who are working here, they can climb up to the water tank for do any of the maintenance process. Okay, and there will be a pump house here at the center of the platform here, and this is a simple system for the water for the water pump system. So when we focus into the cross section of the pillars here, and we use a hollow circular cross section with the outer radius of 120 mm and the inner radius of 100 mm. So now we are going to see the buckling analysis of this structure of the pillar. So first of all, we are going to calculate the area, the cross sectional area of the pillar. We will get 0.01382 meter square, and then we calculate the I. We're getting 1.3349 to the power of -3 meter to the power of 4. Then we calculate for the PCR. So PCR will be getting 1033.160.47 Newton. So then, since the pillar is in a slanting phase with the degree of with angle of 80 degree here, so we will resolve the force into both x and y direction. So we'll get Fy and Fx here. Then we calculate for the safety factor here, and we're getting the safety factor of 4.75, which is more than 3. So the structure is safety and acceptable. So then we will be doing the combined loading here. The combined loading is mainly focused to do the Mohr circle here. So we are doing the combined loading calculation here, and then we do the Mohr circle here, and this is the final answer and final result for the Mohr circle that we have done here.
Okay, now we will focus about the bottom structure of the floating water tank. As you can see, the bottom part of the storage has 3 types of materials. The first one is the platform, the second is the column, and the third is the pontoon. Okay, now I will explain about these 3 analyses. For the first one, lower platform analysis. The lower platform analysis is made of mild steel. The density is 7.85. The yield stress is 370 megapascal. and the modulus elasticity is 70 gigapascal. As we can see, the dimension of the platform is have the 25 meter wide, 25 meter breadth, and thickness is 5.115 centimeter. Okay, the total volume of the platform is 32.1875 meter cube, and the total mass of the platform is 252.67 tons. As you can see, the total bending moment of the platform is, from analysis of the graph, is 267.67, and from this we can calculate the stress working, that is using the right formula, and we will get 184.04 megapascal. From this calculation, we will get the safety factor of the platform, and we get is 2.01, that is above 2, and we can consider it safe. Now we will go to the lower column analysis. For the lower column analysis, the column is made of aluminium. The density is 2.7 ton per meter cube. The yield stress is 210 megapascal, and the modulus elasticity is 70 gigapascal. As we can see, the dimension it made of hollow circular. That is, the outer diameter is 200 millimeter. The inner diameter is 140 millimeter, and the length of the column is 5 meter. And we get the total volume of the columns is 0.3204 meter cube. And the total mass of the column is 0.865 tons. So as we can see, after we calculate the column analysis, we consider safety factor analysis. We calculate the area, where the area is 0.016 meter cube, and the INA is we got is 5.968 times 10 of negative 5 meter 4. And then after we calculate the R, the PCR, the CCR, we get safety factor of the buckle, and the safety factor of the buckle is 5.86, that is considered safe. And then we will calculate the safety factor of the crush, and then we get above 3, and it considered acceptable, and the column is in a safe position. And now we went to the third part of the bottom structure, that is ponton analysis. As we can see, the ponton analysis is also made of hollow structure, that is rectangular. And then we have the total volume is 5.15 meter cube. The total mass of the ponton is 13.91. And from this calculation, we find the draft, and the total draft we get is 2.83 meter. That is, we can see that it's below the 3.5. And then from that we will calculate the buoyancy force and the weight that we will use to find the maximum bending moment from this graph. And then from this we will calculate the safety factor of the ponton, and the total safety factor that we get is 3.02, that is above 2, that is acceptable safety factor. And now I will present the total budget of the floating storage. Okay, from the storage we will use 4 types of materials. 3 types of material. That is, the first one is galvanized steel, the second one is the bias steel, and the third one is aluminium. The total price of per ton for galvanized steel is 3,192 ringgit. The mild steel, the price per ton is 1,197 ringgit, and the aluminium total price per ton is 8,763 ringgit. So after the calculation, the water tank, the upper platform, the pillars, the lower platform, the column, and the pontoon, the total budget, the total price that we get to make this structure is 64,794 ringgit and 4 cents. So the total average is 65,000 ringgit. That's all.